Good morning, my dear students. Today, in this video lecture, I am going to discuss the oxidation of aldehydes and ketone. You know, aldehyde is oxidized to carboxylic acid by using oxidizing agent such as KMnO4, potassium dichromate, KMnO4, that is called potassium permanganate, conch, nitric acid, etc. to carboxylic acid. Means if we consider aldehyde, then it is oxidized to the corresponding carboxylic acid having the same number of carbon as in your parent aldehyde. Now, this aldehyde can also be oxidized by your mild oxidizing agent such as Fehling solution, tolerance reagent, and your Benedict solution. So even by using your mild oxidizing agent such as Fehling solution, tolerance reagent, and Benedict solution, we can oxidize aldehyde to corresponding carboxylic acid salt, or you can say simply carboxylic acid. However, ketones cannot be oxidized. By your mild oxidizing agent, that is your Fehling solution, tolerance reagent, or Benedict solution. So first of all, let us observe the oxidation of aldehyde by mild oxidizing agent, that is your tolerance reagent. What is tolerance reagent? Tolerance reagent is ammoniacal silver nitrate solution. This is your tolerance reagent. So if we use aldehyde and if it is warm with tolerance reagent, if you warm aldehyde solution with tolerance reagent, then we get carboxylic acid and a white shiny silver mirror is formed. So silver will precipitate out, or you can say a white shiny silver mirror is formed. This is also known as your tolerance test, because this test is used to distinguish between your aldehyde and a ketone, because aldehyde will give this test while ketone will not give this test. Now let us suppose if we have aldehyde such as RCHO and tolerance reagent, that is your ammoniacal silver nitrate. So this is your tolerance reagent, which is called your ammoniacal silver nitrate. Then we get carboxylic acid salt along with your silver will precipitate, and this is your NH3. This should be your 2 mole, and then we have water will be there. So what happens? A white shiny silver mirror, a white shiny silver mirror is formed. Silver mirror is formed. So this test is also known as your silver mirror test. क्या होता है जब आप laboratory में, because this reaction is used to distinguish between your aldehyde and ketone. जब आप laboratory में एक test tube ले लीजिए, and in this test tube, if you take aldehyde solution and if you warm with your tolerance reagent, then after some time a white shiny silver mirror, you just observe a white shiny silver mirror will form in this case. So this will confirm the presence of aldehyde, and aldehyde is oxidized your carboxylic acid salt, or you can say simply carboxylic acid. Similarly, next is your here we have perhaps 2 mole of water, so you can correct it. Now next is your Fehling test or oxidation by using Fehling solution. Next is your Fehling test or oxidation by using Fehling solution. Oxidation by using Fehling solution. Actually, Fehling solution is an equimolar mixture of 2 solutions. Equimolar mixtures of 2 solutions, that is your Fehling A and your Fehling B. ये 2 solution का equimolar mixture होता है. One is your Fehling A, another is your Fehling B. Now this Fehling A is your aqueous solution of copper sulfate, while your Fehling B is your alkaline solution of Rochelle salt. अब सवाल उठता है कि भाई Rochelle salt आप किसको कहते हैं? Rochelle salt is your sodium potassium tartrate. This is your Rochelle salt. तो क्या करेंगे हम लोग? एक बीकर ले लेंगे, इसमें मान लीजिए आपने इक्विमोलर Fehling A और Fehling B ले लिया. Now you take in a test tube aldehyde solution. You take aldehyde solution in this test tube, and if you warm with your equimolar mixture of Fehling A and B, then we observe a reddish brown precipitate of. Then we have a reddish brown precipitate of cuprous oxide is formed. Reddish brown precipitate of cuprous oxide is formed. So this will confirm the presence of your aldehyde. However, ketone will not give this test. Ketone ये test नहीं दे. एक और इंपॉर्टेंट पॉइंट इसमें है फैलिंग टेस्ट में कि योर एरोमेटिक एल्डिहाइड will not respond this test. Aromatic aldehyde will not respond this test. जो आपका एरोमेटिक एल्डिहाइड है जैसे कि बेंजल्डिहाइड, तो बेंजल्डिहाइड फैलिंग टेस्ट नहीं देगा. Only aliphatic aldehyde will give your failing test. Now let us see the reaction of this failing test. We have, this is your aldehyde, this we have copper ion, that copper ion from copper sulfate, and then we have OH ion, that is alkaline, we get carboxylate ion. This is your carboxylate ion, which on hydrolysis will give carboxylic acid, and a reddish brown precipitate of your cuprous oxide. So you will get a reddish brown precipitate of cuprous oxide. तो आप देखिए इस केस में क्या होता है, your aldehyde is oxidized to carboxylate ion, however your Cu2 plus get reduced to Cu plus. So this Cu2 plus is get reduced to Cu plus. You know Cu2 plus is your blue color, while this cuprous oxide, it has a color of reddish brown precipitate. So this test is a very important test to distinguish between aldehyde and ketone. This test is also used to distinguish between your aliphatic aldehyde and aromatic aldehyde. For example, you have to distinguish between acetaldehyde and your benzaldehyde. किसी ने आपको पूछा कि भाई एसिटल्डिहाइड और बेंजल्डिहाइड को कैसे डिस्टिंग्विश करोगे? The answer is very simple. Your acetaldehyde, this will give, it will give failing test. It will give your failing test. However, benzaldehyde will not respond to your failing test. Another is your oxidation by Benedict solution. Oxidation by Benedict solution. तो आपको बता दें रिएक्शन इज सेम. बेनेडिक्ट में भी वही रिएक्शन होगा जो रिएक्शन आपने फैलिंग में लिखा है. Because Benedict solution again it is a mixture of Benedict A, Benedict B. In case of failing solution, we use sodium potassium tartrate. In case of Benedict, we use citrate. So in place of tartrate, we simply use citrate. So these Benedict, this failing and this tolerance reagent, they are your mild oxidizing agent, which will which will oxidize your aldehyde, but will not oxidize your ketone. So I think you must have understand what is the oxidation of aldehyde and ketone. Thank you.